Hey guys, we're going to continue working on literal equations. You guys are going to find the first part of this video is very similar to what we did on Thursday, and the second part will be a lot different. So, literal equations, the notes and examples. A literal equation is an equation with multiple variables. All right, so let's look at the problem on the left here. The problem on the left is something that we have been doing in class. All right, so the problem on the left is what we've been doing in class. We draw a river, and then we use the inverse property to move the 5 to the other side, which will leave us with 2x equals 18. The final step that I would do here is I would divide off by 2, and x would equal 9. And so that's a multi-step equation, something that we have been doing in this class for quite some time. All right, now, if you're struggling with those, you're going to struggle with the next part a little bit too. But it also might help you guys to understand the next part. So let's go to number 2, or this same equation, but now it's with variables. So again, I'm going to draw my river, and I'm going to add a b to the other side. So instead of adding the 5, I'm going to add the b to the other side. All right, so this is going to leave me with ax is equal to c plus b. All right, now the second thing that I'm going to do is I'm going to solve for x. So I'm going to divide by the coefficient, which in this case is a. So x is equal to c plus b divided by a. And that is my final answer. So both of these have the exact same processes. The only difference being one of them is done with variables and one of them is done with numbers. So let's do some examples. So you guys had those notes. Let's do some examples so we can further understand how to do it. All right, so number 2, what I've told a lot of you guys in class was that go ahead and label your steps. So here, we're going to label the symmetric property. And then the second step is going to be that we divide by the coefficient. And I'll just write divide. The symmetric property just simply means that we flip this around. The symmetric property simply means this. So what I showed in class today was you just go like this. BH is equal to A. The second step is that we divide. And we divide by the letter we don't want to have in here anymore. In this case, it's B. So we are going to divide by B because I'm solving for H. So it's going to be H is equal to A over B. And that would be your answer. So we've solved it for H. Okay, number 4. Number 4 has the exact same principles to it. We are going to use the symmetric property. And then we're going to drop all the way to step number 9. And we're going to do division. Or divide. So the symmetric property would just tell us to flip this thing around. And the second part is that we divide. And we're solving for the letter T, so we're going to divide it by PR. So T is equal to I divided by PR. Okay? So hopefully I'm not going too fast for you guys. Right now, they really are just almost one step, maybe 2 step if we're going to count the symmetric property as a step. So let's go ahead and we'll look at number 6. So we're doing the even numbers here. Okay. Now, number 6 is a little bit harder than a lot of what you'll see. So this one, we're going to do the symmetric property. Then, so we're going to step 1. Then we're going to do step 9. and divide. But then we have this extra step, and we'll just make it a star step. And this extra step is that we are going to use a square root. Now, a lot of people in this problem, when we first started, they were fine with the symmetric property because I just meant that they flipped around. But they were kind of freaked out because they had a pi logo right there. Think of pi as just simply a variable. So this is going to give you r squared equals pi a over pi. Now, where this gets a little bit crazy is to get this 2 out of here. I have to make it in a radical. So I'm going to take a square root of that because that's the only way I can take 2 of anything out. And so it's going to be r equals the square root of a over pi. Okay. So a little bit tougher of a problem, but very doable. We've done square roots this year. All right, so now if we look at number 8. Number 8 does not have the same steps. Number 8, we're going to still use step 1, which is going to be the symmetric. And then we're going to use step 3, which is the multiplicative property. All right, so the symmetric property says m over v is equal to d. All I did was switch it around. Now I'm going to multiply by the denominator. So we're going to get m is equal to dv. And that is our answer. M is equal to d times v. So we didn't have to divide. So that's an interesting one that we didn't have to divide at all. Number 10, we're solving for b again. So again, I'm going to use the symmetric property. Okay. Then I'm going to use the multiplicative property. And then I'll divide. Okay. So you have 1/3 BH is equal to V. That's all the symmetric property tells us, is that we can flip it around. And I did that because I'm solving for the letter B. I want what I'm solving for on the left. The multiplicative property, multiplying the denominator, it just means that this 3 right here that's in the denominator, I'm going to multiply it on both sides, which will leave me with BH is equal to 3V. All right. Now, the final thing I'm going to do here is I'm going to divide this by H because I'm solving for B. So this would be B is equal to 3V over H. Okay, so it's not always the first number we're dividing by. I'm dividing so that I'm solving for the letter that I want the answer to be for. All right, and all these are real properties. So number 12, I'm going to look at it. I'm solving for the letter B, so it's on the right now. So I'm going to get that over to the left. So I'm going to put in number 12. I'm going to use the symmetric property. We're going to use the symmetric property. Then I'm going to put in number 3, which is multiply. And then the 9th thing I'm going to do is, we aren't going to do that actually. We're going to do the multiplicative property. I get in such a habit of doing that, but we're actually going to do the seventh property, which is the inverse property. Okay, and that should end our problem. So setting it up so I know what I'm doing always helps me tremendously. So B plus C over D is equal to A. Okay? Now I'm going to multiply this by D. And that will leave me with B plus C is equal to AD. Now, the final thing I'm going to do is the inverse property. Remember, I'm solving this for B. All right, I'm solving it for B, so I want that C out of there. So the inverse property would say I just subtract it out. So I subtract out the C on both sides, leaving with B equals AD minus C. All right, and that would be my answer. All right, so number 14, we're solving this for y. Now, y is already on the left side of the equation, so I don't need to use the symmetric property. So here, I'm going to start with the seventh property, which is the inverse. And then I'm going to end it with dividing. So dividing is an important process in what we're doing here. So I'm going to subtract AX from both sides. And the order does not matter, but the sign in front of it will. So you can have C minus AX, or you can have negative AX plus C if you'd prefer. And now I'm simply going to divide this by B. So y equals C minus AX divided by B. And again, you could have had negative AX plus C over B if you wanted to. Both of those are the exact same thing. So number 14 was interesting because we didn't start with the symmetric. We started with the inverse, and then we went right into dividing. All right. Now, number 16, again, we have this T over here, so we're going to have to do symmetric. And then, I kind of just do it in my head, I'm going to do the inverse because I see an addition sign. And then I will do the division. So the symmetric property would tell me that this would be P plus PRT is equal to A. Okay, the inverse property would tell me that I'm subtracting this P out of here. Because remember, I'm solving for T. So I want to get that P out of there. So PRT is equal to A minus P. Now, dividing, I'm going to divide out the PR on both sides. Now, when I divide off the PR, I'm going to do it on both of those individually because we're going to find that one of them gets a little bit smaller. So T equals A over PR minus P over PR. Well, that's going to be minus both of these P's can eliminate. And that's going to be 1R. All right, and we learned that in a past unit when we did exponents. Now, number 18 is the final problem that we have. This one looks very difficult. It's really not terrible. We're going to be solving it for B1. Okay, now, we're going to still go through our step-by-step process. We're going to use the symmetric property. Then we are going to use the multiplicative property. Okay, so that gets that out of there. Okay, then we are going to distribute. Actually, let's get to here and let's see what we get when we get to there. So we're going to make this 1 over 1/2 h times b1 plus b2 is equal to a. Now I'm going to multiply out this denominator. So I'm going to multiply out the 2 on both sides. Those are the 2 steps that I visually could do immediately. So that's going to be h times b1 plus b2 is equal to 2a. And usually you just put the number first. Now, the next thing I believe that I would do here is I would divide. All right. Now, I could certainly distribute here if I wanted to, but this is where we have to get a little bit creative in what we're doing. I could certainly distribute and then divide things out. So maybe just based on our rules, I'll do that. Normally, I would divide out the h and then use the inverse property, but I'll do it this way. So this will be hb1 plus hb2 is equal to 2a. All right, now, the next thing that I'm going to do, because I'm solving for b1, is I will use the inverse property, which is 7. So I have hb1 is equal to 2a minus hb2. All right, and this is just almost to prove that this process will work every time. And then I'm going to do the 9th thing, which would be divide by the letter in front. So we're going to have b1 is equal to 2a over h minus, those eliminate, b2. All right, so this is one that had a lot of steps to it, and you've really got to know what you're doing. Now, there are some people that would have done it differently, and that is fine. You can do it as differently as you want, but you do need to get to the right answer. So that gives you an idea of what we did in class today. So if you did not get the odd numbers, we did those on Thursdays, and those are still up for you to look at. But there are your answers to what we did today. So thank you guys for your attention, and I look forward to seeing you all in class again later on this week.